We're the heart detectors. My name is Anika.
I'm Anvita.
And I'm Rose. This is our product name, HEART, which stands for High Tech, Eco-Friendly, Advanced, Reliable Technology. And this is our logo.
We're from the Ann Richards School for Young Women Leaders, and we're in 9th grade. My role was a project manager and the coordinator.
I was the marketing manager.
And I was a creative design lead. This was the method we used for our project, the engineering method. And our current status is to develop and prototype our solution. And this is what we're going to be talking about today.
Number 1, the problem. 2,400 is the estimated amount of deaths every day due to cardiovascular disease. Our goals are to prevent, predict, or detect cardiovascular disease. Nearly half of people who experience heart attacks don't know they're actually having one, and these types of heart attacks are called silent heart attacks. 45% of all heart attacks are silent. My grandfather a couple months ago experienced a silent heart attack in his sleep. The only symptom he felt was a bit of twitching in his left arm, and he was able to figure out that he had had a heart attack by needing to go to the hospital a couple days later from an infection.
Research. Heart attack symptoms between genders. Male usually have shortness of breath, squeezing chest pressure, discomfort in arms, jaw, or neck, and cold sweats. Female usually have nausea or lightheadedness, unusual fatigue or fainting, shortness of breath, chest discomfort, but not always, pain in arms, jaw, neck, or upper back. Why is a silent heart attack different? A silent heart attack is one that has few, if any, symptoms or signs that you don't identify as heart attack symptoms. Men are more likely than women to have silent heart attacks. However, women are more likely to die from silent heart attacks. Furthermore, the risk of dying from heart disease after having a silent heart attack is 3 times higher than for someone with a normal ECG. Goal number 1, preventing a heart attack. Since heart disease is one of the leading causes of death in the U.S., there are several ways to prevent it and reduce the risk. For example, no tobacco use, lower blood pressure and blood sugar, aim for healthy weight, reduce cholesterol, exercise daily, eat healthy, and reduce stress.
How to detect a heart attack on an ECG. So as you can see here, this is a heartbeat that has been recorded on an ECG. And this little wave here is called a P wave. And that little dip is called a Q. The spike is called an R, and the little S line or dip stops above the baseline. And if it stops above the baseline, that means you are currently experiencing a heart attack.
The different types of heart attacks. STEMI is a type of heart attack that mostly affects the lower chambers of your heart. Intense discomfort or pressure in or around the chest, often extending to the neck, jaw, shoulder, or arm, is the most common symptom of a STEMI.
A non-STEMI is a less serious type of heart attack than a STEMI because it causes less damage to the heart. A type of heart attack that involves a partial blockage of one of the coronary arteries, resulting in decreased oxygen-rich blood flow to the heart muscle.
And the last kind is coronary spasm. A coronary artery spasm occurs when the walls of the heart muscle start to tighten, and that restricts the flow of oxygenated and deoxygenated blood throughout the heart. And when this happens, well, you have a coronary spasm heart attack. But coronary spasm heart attacks are usually short and temporary. And our third goal is to predict. And we researched different kinds of heart pulse monitors for this. The two we found were most similar to what we had were a Holter monitor and an event recorder. And we sort of tried to reverse engineer these along with a couple others to try and make our own original patch.
Our product. Our product is a patch that monitors heart rate. It is placed on the left side of the chest. It is lightweight and wire-free, records heartbeat, and creates a strong vibration when irregular heartbeats are detected.
And these are the materials that we used. And we used an elastic polyurethane, a cardiac sensor, an NFC power, a vibration sensor, a 2032 battery, a polyamide substrate, a conductive hydrogel, micropore paper tape, and a foam spacer. And the total for one patch would be $20.64. And these are our diagrams. The one on the left is a more spaced out version of our patch, and it would be 3 inches by 4 inches. And the one on the right is where you would be able to place the patch on your body in order for it to effectively record your heartbeat.
And this is our on-shape diagram, which as previously said is 3 by 4 inches, and it includes the vibration sensor, antenna, cardiac sensor, 2032 battery, and NFC power.
Next steps in future improvements. Characterize resting and max pulse among age groups and activities, 3D modeling parts and assembly/programming, explore material properties and concerns/improvements. We will also do a heart attack info campaign this month on campus since it's National Heart Month to address the prevent portion of our goals.
Future improvements. We want to make an app that can display the data that the patch collects with personalized information from the user, like previous heart problems, diabetes, high blood pressure, and similar things. We want to make customizable patches, find better batteries, look at cheaper chips for the sensors, make the sensors waterproof, create a kit that includes a cleaning wipe, and understand the innovations towards a wearable ECG.
This is how our experts helped. Lori Hauk, she is a cardiac nurse, and she explained to us how to detect a heart attack on an ECG. She also changed our product to detect irregular pulse.
Megan Bangs was a general practitioner and is currently a medical consultant. She explained to us how ECG machines are not perfect because it depends on the size of the person's chest. And we wanted to change our product by kind of making it the patch multiple sizes depending on the person's chest.
And our last one was Jean Ann Booth, who is the CEO of Renaliware, who explained to us the safety guidelines in order to transfer information from a wearable to a device and the difference in clearance for medical devices versus consumer ones. And these were our sources.
Thank you.
Any questions?